Good everyone, my name is Graphics. If you look at the front of your screen, you see a problem, and the problem is related to open channel flow, where we'll be looking at a rectangular channel. The question says, find the rate of flow and conveyance for a rectangular channel 7.5 meter wide for uniform flow at a depth of 2.25 meter, having bed slope as 1 in 1000. Take cheesy constant c to be equals to 55. Now, the first thing you have to do, we have to write out the parameters given. Now, we're told to find the rate of flow. The rate of flow is called the discharge, right? Always in meter cube per seconds. We're told to find it, so Q is used to represent the discharge is equals to this. Now, we're given the width, right? How wide the rectangular slope is, and it's given to be what? Represented with B, which is 7.5 meters. And the depth of it, right, which is given as Y, that is how the level of the fluid inside is given to be what? 2.5 meters. In some cases, they use D to represent the Y. And the bed slope, right, is given to be, we have always as S naught, which is given as 1 over 1000, 1 in 1000, right? And the Chise constant, 55, is that taken? Now, this is how it is diagrammatically. Let's say this is the section of our rectangular channel, right? And the distance with the depth here, the distance, we call it it is 7.5 meter wide, B. And the depth of the liquid, let's say this is the liquid here, is given to be 2.25, right? So the first thing we should do here is to calculate for the discharge. We know the discharge Q is equals to what? The wetted area times what? Times the velocity altogether. And since we need to, for we to get our discharge, we need to have the area and we need to have the velocity. But we don't have any of that in our parameters, so we have to calculate for it. So for the wetted area, if you recall, it says it's rectangular in nature, as in the shape of the channel is rectangular in nature, and it is giving us length times breadth. So in this case, we say the wetted area here is given as what? The length here is given as the width of the channel, which is which is B, and the breadth here is given as the depth of it, which is what? Given as Y. Right? So we say A is equal to B times Y. And that will give us 7.5 times 2.25. And if you multiply that, your area will be equal to 16.875 meters square. So that is our wetted area, right? Now, for velocity, we know that the velocity is given us the Chise constant multiplied by the square root of the radius of the hydraulic radius times what? The bed slope, right? So now if you look this closely, we don't have the hydraulic radius, neither do we don't have the hydraulic radius. That's the only thing we don't have here, so we need to get it for we to have our value here. So we'll call that equation 2. The first one here is equation 1, this is equation 2 here. Now for the hydraulic radius, R is giving us wetted area over wetted perimeter, right? Now the wetted area we know earlier is given as what? The width times the what? The depth, right, of the channel, all over the wetted perimeter. If you have the rectangle this way, if from here to here is Y, here to here is also Y, the depth, and the base here is what? Is B. Perimeter is adding all the side. They call it wetted perimeter, where the liquid is touching, right? Not the surface but the sides. So we have Y plus B. I will know Y plus Y is 2Y then plus B. So the wetted perimeter given as what? 2y plus b. Now this will be equals to, we know very well that our weighted area as calculated from equation 1 given as what? 16.875. Is that taken? All over the weighted perimeter, we know we have 2 into bracket, our depth is 2.25 plus 7.5, and everything will give us 16.875 divided by 12. So our hydraulic radius will be given as 1.406 meters, right? So since we've gotten the hydraulic radius, we have our bed slope, we have our artificial constant. Now we'll now equate these values into equation 2. So substituting arrow and the S naught and C into equation 2, we'll say that the velocity will now be equals to, instead of me putting the C, I'll put 55 times the square root of, instead of me writing the arrow, I'll write the value of arrow, which is 1.406, times, instead of me writing the bed slope, I'll be writing the value of it, which is 1 in 1000, which is 1 over 1000, that will give us 0.001. So we'll now move forward and say that our velocity will now be equals to 2.06 meter per second by the time you multiply everything we have here. Is that okay now? First of all, you calculate, multiply the inside 1.406 times 0.001, you look for the square root and you multiply by 55, you'll be having 2.06 meter per second. Now we've gotten the velocity now, and we have the weighted area also. So you now substitute this value, substitute velocity and area into equation 1. So the discharge now, Q, will now be equals to area times velocity, which is given as, the area is given as 16.875 times velocity, which is what? 2.06, right? So we say that the discharge will now be 34.76 meter cube per seconds altogether. So this is the discharge, right? The rate of flow, is that the key of the given channel you can see on the screen. So this is how you go about rectangular flow. In our next video, we'll be looking at the triangular channel, right? So you just stay tuned for our next video. So if you have found this video helpful, please don't forget to like, subscribe, and also share the video. Thanks for watching.